There we go. Sorry about that, everybody. So we had some technical issues, but we're back now, and now we're going to go through grade 11 factoring. What's the difference between grade 11 factoring and grade 10 factoring? Degree of difficulty. First page is pretty much a review of anything a strong grade 10 student should have been able to factor. So let's try these together, shall we? You should be able to look at this and go, aha, there's a common factor of 5, a common factor of x squared, and a common factor of y, leaving behind 1x, 3, and another y, plus 6, x squared, and y to the 4. So that's always, they put this as number 1 for a reason. The first thing you should look for when you're factoring is a common factor. Then there's the type of factoring we call difference of squares. And a difference of squares factors into what we call conjugate pairs. This one would be the square root of 9y squared is 3y. So there's a 3y here and a 3y here. And the square root of 100 is 10x squared, right? So plus 10x squared. And this one, did anybody manage to factor that? No, it was messing with you. That one there does not factor. Hey, what do we call something that doesn't factor when you're just talking about numbers? What do you call a number that doesn't factor? Yeah, it's prime. So this is like a prime binomial. Does not factor. All right, simple trinomials. And they're simple because the coefficient on the x squared is 1. So you know you get x squared from going x times x. And we've been doing lots of this factoring already, so this should be fairly old hat for you. The two numbers that times to make 10 and add to make 7 are 5 and 2. And the two numbers that times to make negative 15 but add to make 2 are positive 5 and negative 3. Complex trinomials, where the number in front of x squared isn't a 1, you could still try to do it this way, but I prefer the decomposition method. 5 times negative 6 is negative 30. What two numbers multiply to make negative 30? But they'd add together to make positive 13. And the answer to that is negative 15 and positive 2. So you decompose 13x into 15x minus 2x.
It should be positive 15 and negative 2.
And that's what I wrote down here, but I forgot to put it that way. Thank you very much for noticing my goof up. So it's plus 15 minus 2. And then you do what's called partial factoring. You factor 5x out of here, leaving me x plus 3. And you factor a negative 2 out of here, leaving you x plus 3. And if these two brackets don't agree with each other, and they're not the same, something's going wrong. Perhaps it doesn't factor and you think it can, but it can't. Now I factor out the x plus 3, and the remainder is my other factor, 5x minus 2. Boom. If any of this page was a challenge for you, you need to maybe go back and review some grade 10 factoring. You can go back to the FRC videos page and go back to last year's MEAP course and practice up your factoring. I'm going to skip the intro there, and let's go on to the next page. Let me make that bigger so we can see what we're doing. Okay, there we go. All right, and of course we already know this from last chapter. A quadratic equation is any equation that can be written in the form ax squared plus bx plus c. And you could say, I guess, that equals y. And a, b, and c are constants, and a, of course, is not equal to 0. And the shape of this is, of course, called a parabola. So this is just a quick review of how we started last unit, chapter 3. And here's a couple of examples of parabolas. And the approximate x-intercepts for this parabola look like they're about, I don't know, so maybe about approximately 0.4 and say 5.6 maybe. And my approximate x-intercepts here are negative 1, negative 2, negative 3, I don't know, negative 3 point maybe 1. And then that one's the same on the other one. This one has symmetry, so the other one would be maybe positive 3.1. And of course, as I pointed out in chapter 3, we learned how to factor so that once we get to a factored form, we can use that to solve equations. Right? If this number times this number is 0, then x is either 9 or it's negative 3, because those are the two numbers that would make these factors 0. Think of it logically. If a number times a number is 0, one or both of those numbers must be 0. Here, a number times a number is 0, so the first number could be 0 itself, or the next number could be negative 12. All right, these two I actually have to factor myself before I can solve for x. So what two numbers times to make negative 28 and add to make positive 3? And the answer to that is positive 7 and negative 4. So the two answers here for this equation's x are negative 7 and 4. This one I would factor by common factors. Take out an x, and it looks just like the one above it. X is either 0 or 7. The answers to a quadratic equation are also called zeros, for exactly the reason as we just saw above. It's the place where y would be 0. All right, so first, let's not do any equation solving, let's just do some factoring. So this guy, which of the 4 types on the first page is this guy? That's a difference of squares. So that's 4x plus 5y and 4x minus 5y. This one is 3x plus y over 10 and 3x minus, that's supposed to be an x, minus y over 10. All right, and at this point, if you haven't tried these yet, if there's people watching at home here, pause the video and try the rest of them yourself, and then turn the video back on when you're ready to go through the answers. All right, let's go through them. I do this one by decomposition. 4 times negative 5 is negative 20. What two numbers times to make negative 20 but add to make positive 8? 10 and negative 2. So this is 4x squared minus 10x, plus 10x, minus 2x minus 5. I'd factor out a 2x out of the first two, giving me 2x plus 5. Then I'd factor out a negative 1 out of the second two, giving me 2x plus 5. So my two factors are, sorry, I'm kind of out of room there. My two factors are 2x plus 5 and 2x minus 1. What do we do with D? Well, how about with D, we do a substitution. Let u equal x plus 3. So now, this is 2u squared minus 11u plus 15. Okay, so let's factor that. What two numbers times to make 2 times 15 is 30? Two numbers at times to make 30 that would add up to make negative 11. Negative 6 and negative 5. So this is 2 times u squared minus 6u minus 5u plus 15. So now I'm going to factor out 2u, leaving me u minus 3. And I'm going to factor out negative 5, leaving me u minus 3. So my two factors, and again, they don't give me a whole lot of room here. My two factors are u minus 3 times 2u minus 5. But wait, u was something we added to the equation. U is actually x plus 3. So replace the u with x plus 3 again. And look how that turns out. You end up with x plus 3 minus 3, which is just x. And then over here you get 2x plus 6 minus 5, which is 2x, and 6 minus 5 is plus 1. Is that the only way to approach D? No, if you really wanted to, you could expand these things, collect like terms, and then try to factor. But I think that's probably more work. You can try it if you want. We expect you to be able to do it this substitution way when we give you one of these. Because this substitution method is something that we'll use quite a lot when we move on to calculus. So it's a very handy tool for your toolbox. My algebra is too complicated to want to work with the way it is. Let's substitute in something to make it look less complicated. That's a very powerful tool. Okay, what do you want to do with E? Do you really want to work with fractions? Me neither. Let's factor out a quarter. That's my common factor. So think about it. A quarter times whatever goes here is negative 1x. So notice that's going to be negative 4x, because a quarter of 4 is 1. And a quarter times whatever goes here is going to be negative 3. So that's going to be negative 12. Oh, isn't that nice? So this is going to be 1/4 times x. What two numbers times to make 12 add to make 4? -6 and +2. Don't lose that quarter. It belongs there. It's a factored form. F, we're back to difference of squares. 3x plus 0.8y, 3x minus 0.8y. This is something that came up last unit a couple times. Perfect squares don't have to be whole numbers. Some decimals are perfect squares, like 0.64 is 0.8 times 0.8. For G, I'm going to use the same strategy I used for E. 1/2 is going to factor out first. Everybody see how I did that? Now ask myself what two numbers times to make -8 and add to make -2. And that's -4 and +2. H is another perfect square, difference of squares. So that's 0.7y plus 6x and 0.7y minus 6x. And I am going to do a double substitute. I'm going to let A equal 3x plus 1, and I'm going to let B equal 2x minus 3. So this is A squared minus B squared. And that's super simple to factor. That's just a difference of squares. It's A plus B, A minus B. But of course, A and B aren't the actual variables from the question. So go back and substitute what I substituted in. So 3x plus 1 is the A, and the B is 2x minus 3. Now careful with the next one. Maybe I'll use another bracket. A is, of course, again, 3x plus 1. But when I substitute back the B, remember I'm subtracting the B. So without this extra bracket, you're going to get the wrong answer. All right, the first one is going to simplify to 5x minus 2. And the second one's going to simplify to 3x minus 2x and 1 minus -3. And I think that's much less work than expanding these two things, collecting like terms, and then trying to factor it into these. But try it if you want. It will get you the same answer. But this is the way we expect you to do it as a grade 11 student, heading into calculus, the substitution trick. Nice, handy little tool for our math toolbox. Let's use it one more time. How about we'll use x. Let x equal n plus 3. So this is -2x squared plus 12x plus 14. I'm going to factor out my common factor of -2. And then I'm going to ask myself, I'm going to say self, what two numbers times to make -7 and add to make -6? It's -7 and plus 1. And then I'm going to say, oh yeah, but the question isn't about x, it's about n. So put back the n plus 3's, and you'd get n plus 3 minus 7, and n plus 3 plus 1. And there we have it. That's the grade 11 level of factoring. Notice it's the same stuff you did in 10, just a little more complicated. And again, what are we doing this for? Oh yeah, so we can solve stuff like parabolas. So let's solve some equations now. And again, if you're doing this video from home and you want to pause it and try these yourself, go ahead. But here in the room, we're going to just work through these together. Normally, when you do algebra, you'd think, oh, I'm ready to start solving here. And when you're doing linear algebra, you put all the variables on one side and all the constants on the other. When you're doing quadratics, and you see an x squared, you move everything to one side. That way, you can try your factoring. And if it doesn't factor, you could always complete the square. And if you don't want to complete the square, we have another strategy coming for you in a couple days. It's very powerful, called the quadratic formula. But right now, that totally factors. What two numbers times to make 6 and they're 1 apart? +3 and -2. Now this time, the difference between these questions and these questions is that none of these guys were equations. This is an equals. I can actually tell you what x is, or in this case, what they are. There's two of them. X could be -3, and x could be 2. And again, why are these not the answers here? Because these aren't the zeros yet. -3 plus 3 is 0, 2 minus 2 is 0. You get the idea. All right, B, step 1, everybody out of the pool. One side has to be 0. Step 2, I'm going to factor out a 2, but notice when I factor a 2 out and it's an equation and the other side 0, I can actually just ignore it now. Because think about it. Here, I'll do it in 2 steps. I took out a 2, and then I divided both sides of the equation by 2. Now it's just this, right? So again, we've seen this trick in chapter 3, but here we are doing it a little more formally. What 2 numbers times to make 12 and they're 1 apart? I think we're looking at plus 4 and minus 3, correct? And so my 2 answers are negative 4 and 3. All right. Feel free to ask questions. I know this is the first time I've recorded a video while you're here. I won't use your name. I won't say, hey, you Tyler, that was a stupid question. There's no Tyler in this class. So. And if there was, I wouldn't say that. So I won't name you by name when I make a video, because I do put these on YouTube. The division doesn't like me putting my videos on YouTube, but they can fire me. When students are watching videos on YouTube, of course, they can switch over and get the auto-translate on so that they can close caption in their own language. And I know it comes out kind of not looking exactly like your language, but it's a heck of a lot closer than trying to understand me when your English is kind of not 100%, right? So that's an advantage I don't want to take away from students. That stupid Microsoft, what's it called again? Microsoft Teams, yeah, Teams Share or whatever it is, yeah. No, what was it called where they store the videos? SharePoint? Yeah, there's no auto-translate for that, right? Whereas YouTube has that. So I don't want to leave YouTube. I'm not monetized or anything. I'm not getting anything out of YouTube. I think it's just an enormous advantage for students. So I'm going to keep doing it, even though, again, the division would rather I didn't. Anyways, okay, what are we doing now? Everybody out of the pool. Okay, I could move these 2 to the right, but it'd be kind of easier if that coefficient on x squared wasn't negative. So I'm going to move that to the left. So I'm going to add 3x squared to both sides of the equation. And now it's 0. And now, I'm going to use the decomposition method on this one, I think. 3 fours is 12. What 2 numbers times to make 12 and they're 4 apart? 6 and 2. So I'm decomposing 4x into plus 6x minus 2x. And then I partially factor. I take out a 3x. And I take out a minus 2. And now I factor out x plus 2. And careful with this one. This is easy, right? X is negative 2. But what makes this 0? And if you can't just look at it and tell, actually make a little equation where it equals 0 and solve for x. Add 2 to both sides, and x is equal to 2/3. So my 2 answers there are negative 2, and yep, answers can be fractions. But we kind of know that, right? Look back at that example we did a couple pages ago. We had to estimate where the x-intercepts were because they weren't right on the grid lines. So that's going to happen sometimes. You're going to get fractional x-intercepts. All right, everybody out of the pool. Now what? Oh, that almost looks like it could factor, right? There's a 2 in the 4 and the 18, but there's no 2 in 21. Nope. All right, what's 4 times 18? I don't even know what 4 times 18 is. I got to think about it. 72? What 2 numbers times to make 72 and they're 21 when they're apart, right? Because this, I guess this should be a negative, right? So they're 21 apart. So don't worry about 8 and 9. That's too close together. Start thinking about the numbers further apart. They got to be 21 apart. So 1 and 72, and the bigger one's got to be the negative. That's too far apart. Getting warmer. I think that's our winner right there, isn't it? 3 and 24? So there we go. 4x squared minus 24x plus 3x minus 18 equals 0. Usually somebody asks if when I'm doing this with the grade 10s especially, what if I put the plus 3x first? Would it matter? And the answer is no. Try it if you don't believe me, but it'll factor the same way. So take out a 4 and an x, and I get x minus, what is that, 6? Take out a 3, and I get x minus 6. And then take out the x minus 6. And okay, careful with this one now. This one's easy. X is 6. But see if you can do this one without actually solving it as an equation like I did over here. If 4x plus 3 equals 0, the 3 moves over, becomes negative. X is negative 3/4. There you go. All right. Now a couple of difference of squares. I know what you're saying. You're saying a 12th isn't a perfect square. Fine. Let's make it a perfect square. Times both sides of this equation by 12, and looky there. 36 and 1 are both perfect squares, aren't they? So that's 6x plus 1. That's 6x minus 1. This would be x equals negative 1/6, and this would be x equals positive 1/6. Isn't that nice? What would you do with f? Do you really want to work with those decimals? I want to work with those decimals about as much as I wanted to work with this 12th. Kill it. Kill it with fire. What could you times that equation by that would make the decimals go away? How about you times both sides of the equation by 100? 100 makes that 50x squared. 100 makes this 2. And 100 times 0 is still 0 last time I checked. You're probably looking at it going, hey, that's still not a perfect square. It is if I factor out a 2 now. Numbers are your puppets, make them dance. Ha ha. Isn't that nice? 5x plus 1, 5x minus 1, and my two answers for that are x equals negative 1/5 and x equals 1/5. And I hope you noticed that for both of these we could have solved them a different way. Let's go back to E for a sec. I could have done this by straight up algebra if I wanted to. I could have just moved the 1/12 to the other side of the equation, divided both sides of the equation by 3, which would be 1/36 now, and then square rooted both sides, which would be plus or minus this, which would be plus or minus 1/6, which is what I got over here. If you like that better, by all means, you could do it that way. But I was having so much fun factoring that I didn't want to stop. Oh, this one's no fun. It's factored for me already. Oh, but wait a minute. See the problem with this one? This side isn't 0. So I can't just guess. Oh, I could start guessing what the factors of 24 are, but there's kind of a lot of them. What should I do? What are you thinking?
You can set a equals to x minus 2 and the equation
Ooh.
times a plus 5 equals to 24. And then you find 24 is equal to a times 3 or negative a times negative 3.
So the microphone is probably not picking you up from way over there. People watching this video, somebody liked my substitution strategy from the last batch there so much that they put it in here. You could let a equal, say, for example, x minus 2. And then if, for example, a is equal to x minus 2, then think about what you have to do to x minus 2 to get to x plus 3. You'd have to add 5. So x plus 3 would be a plus 5. Whoa, isn't that cool? So you could do that. That's not quite exactly the way she did it, but that's another way. But I'm actually not going to do that. This time I am going to expand. I'm going to expand this and get x squared plus x minus 6 equals 24, and then I'm going to do everybody out of the pool. So the substitution's a cool idea, but I don't need it for this one. Feel free to try it if you want. But I think this one's going to make my life a little easier, because 30 is an easy number to factor in, to find factors that are 1 apart. Quick, what two numbers times to make 30, and they'd add to make 1. Remember, one of them has to be plus and one of them has to be minus. So yeah, it's going to be 6 for the plus and 5 for the minus. So that means my two answers are x equals negative 6, and x equals 5. Interesting though. Try that substitution yourself and see if you can figure it out that way. That's pretty neat. All right, that is how we take grade 10 and 11 factoring, and we use it to help us solve equations that have x squareds in algebra. So that's kind of the first lesson here. It's actually a combination of grade 10 review and 4.2 in your textbook. So the assignment for, or part of the assignment for 4.2 is this. I promise my guys the guys who are in the room right now as I make this video are getting a test tomorrow. So I promise them they don't have to start this assignment till next week. They can have the weekend off after they write a big Friday test. But people watching this video, try some of those questions. And there we go. All right. We'll stop this video there. And then we're going to look at some 4.1 stuff. So let's see. Okay, video